Didn't even start. I didn't even start. So I went through this. We're going to have to recap what we did on the first slide. My bad. So our aim for today is graphing complex numbers. Complex numbers get graphed on this complex plane. The only difference between it and the normal plane is that there's an x-axis, and then there's a y-axis. Whenever you're trying to graph complex numbers, that's this right here. You graph them like vectors. You always start at the origin, and then you graph the complex number. This first part is the x, however much you're going to go in the x direction, and this is however much you're going to go in the y direction. So start here, go over 2, up 2i, put a dot, and connect them, and that's the complex number 2 plus 2i. So we're going to do this now. So now we're going to be graphing two different vectors, and we're also going to be graphing their sum. I'm going to do the first vector, z1, which is 1 plus 5i, in red. So I start over at the origin, I go over to 1, and I go up to 5i. There it is. That's A. Let's do z2 in green. I'm going to go over 6, and then I'm going to go up. First of all, whoops, I forgot. I'm going to start at the origin. I'm going to go over 6 and up 2. And there is z2. Piece of cake. Finally, let's find the sum. Obviously, you know, like z1 plus z2 is 1 plus 5i plus 6 plus 2i equals what? 7 plus 7i. And then if you graph it, right, we go over 7, and then we go up 7, and there's the sum in blue. And what you can do is you can think of it as forces. The red force, almost as if you had a slingshot, right? One force acting on it from the left, one force acting on it from the right, and then your projectile traveling along this path. All right. Right now we're going in which, our next question is in which quadrant does the difference of those two complex numbers lie? Here we've written it out, we've shown distributing the negative, and we got our final answer. And over here, this is the quadrant system. We talked about how stupid this is. Why can't it just go in a normal order? Yeah, which quadrant is it in? Quadrant 2. Right? That's a very common Regents question. So let's talk. This is the last kind of question that you'll see in terms of new stuff. Finding the absolute value. A synonym for absolute value, in other words, another word for it, is magnitude. Finding the absolute value or the magnitude of an imaginary number. How do you find the magnitude of 4 minus 3i? I'm going to show you the real short way, the way that I want you to do it, because this is, if anything, just a multiple choice question. And then in part B, I'm going to show you how to do it the long way, because anybody aspiring to be a mathematician, you should see how we tackle this and how your calculator's programmed. Guys, turn on your calculators. Right? First thing we got to do is hit the mode button, and you got to make sure that you're in A plus BI mode, or else you're going to get some random error message. Okay. Then the next thing you're going to do is you hit the math button. I mean like magnitude, absolute value. We got to go to math, we got to go to num, ABS for absolute value. And then it's 4 minus 3i. Whoops. 3i. And then you hit enter, and that's it. That's all you do. Wow. Yep. The magnitude. In other words, what does the magnitude refer to? It's the size of a number. Size of a number, it's telling you how big an object is. Okay, now let's try and do it for part B. I'm going to show you the kind of error message that you're going to get. Now your calculator also does cut and paste. Do you know this? No way. Oh, cut and paste. Like, in other words, you don't have to be retyping everything in if you get a mistake. Here's how you cut and paste. Everybody look at the bottom of your calculator near the enter button and the negative symbol. You see something written in yellow that says entry or answer. What I want to do is I want to copy my entry. So you do second and the enter button, and you automatically get it again. And you could just move over it and type whatever you want in. So you can use this in case you're on a test, you like punch in some long formula, you realize you made a mistake. You don't have to retype it all. You can just cut and paste and keep entering in. Hit the enter button. Okay, maybe this can be turned into a fraction by your calculator. Maybe. Math, frac. Nope. So if it can't be turned into a fraction, what kind of number is it? It's irrational. Okay. So if you're on a test, and you punch this into your calculator and you get an answer that looks like this, how could you use this on a multiple choice question?
Plug in the thing and see which one matched up.
Perfect. Yeah, you're just going to plug in the multiple choice answers and find the one that matches. But I'm going to show you how we could get this number the long way. So bear with me for una momento, por favor. Anybody, any aspiring mathematicians out there? Here's what you do. You see 2 plus 6i? 2 plus 6i, if you graphed it real quickly, looks like this. Do you see that? Okay. Now let's talk about this for a minute. Take this, we're going to talk about it. Here's what's really going on here. You've got a vector that looks like this, and we need to know its size. What in math, how do you normally figure out like size, like distance? And what about in geometry? How did you find like the size of or the length of a side of, I don't know, like a triangle? Like the length of the side of, I don't know, like a right triangle. Very nice. So check this out. Sneakily, this can be made into a triangle. Right? How many units did you go this way? 2. How many units did you go up? 6i. Yeah, we did go up 6. But really on this grid, to make so that it's more accurate, we went up 6i units. Now to find the length of the hypotenuse, guess what we're going to use? C squared is going to be equal to 2 squared plus 6i squared. And so C squared is going to be equal to 4 plus, let me put this in parentheses, negative 36. And then you run into some trouble. And this is where being a mathematician and understanding what everything means comes into play. I love this. It's the most creative part of math. You run into trouble because having negative 36 in that formula doesn't really make any sense. Can a distance be negative? Nope, not anymore. Once you square it up, the I gets taken away. It's a real number because I squared is negative 1. So can you have a negative distance, yes or no? Can the size of a side be negative? No, that doesn't really make any sense for the side of our triangle to have like a negative 36 as for its distance, right? So this is how you take out negatives. When mathematicians just want to examine the size of a particular length, irrespective of the difference, what do they use? Does anybody know? If you just wanted the size of a particular length, what mathematical operation would you use? Not the square root, but you're real close, which means you're good at this. No, it's like an operation. It's a thing, square root, squaring. It's something that helps you figure out the size of an object, the distance of an object. Go. That's true, but I'm talking about we need to find out how big negative 36 is. What in math does that? What? Nope, it's even easier. The absolute value. The absolute value of anything, that's what absolute value does. That's why when you stick a negative inside an absolute value, you know what you always get out of it? Positive, because it tells you the size of a number. Alicia's real smart. That's how she knew. right? Square root of 40. Then finally, c is going to be equal to 2 square root 10. I got that because radical 4 times radical 10 is 40. And the square root of 4 is 2. And now let's just check to make sure, once again, this is the long way. You will never have to do it this way. You get that same answer. And that's why it's the case. But from here on out, do me a favor, just use your calculator. Just use the absolute value function when you're talking about magnitude, and you're good to go.